Welcome to this technical teardown of our 60 kilowatt battery energy storage system power conversion system. This system pairs a 177 kilowatt hour LFP battery rack with a high efficiency, two-stage power conversion architecture. In this video, we walk stage by stage through the single line diagram, moving from DC storage to C-grid injection. 27 kilowatt hour LFP battery rack, configured at a 150 big 1 pm string, using prismatic elm. It operates the throttle voltage window of 440 to 642.4 volts, with a nominal voltage of 563.2 volts. Internal monitoring is managed by levered CST slave BMS storage featuring passive balancing networks and NTC temperature and here for safety. The rack incorporates a mid-train service disconnect and the high voltage interlock loop running through all common. Moving into DC protection and isolation, the positive and negative VT lines path manipulation which SW1 and main DC through the F1 and F2 to prevent massive inrush current storing started. A contactor K1C engaged first for a 47 ohm at 100 watt precharge resistor. Once at a time, main contactors K1 and K1B close. List stage also includes surge protection device STD1 and common mode choke CMC2 for EMI suppression. DC to DC converter. Lift 2 faint design using inductor L1 and L2 with silicon carbide power module Q1 and Q2. Unit steps on the fluctuating battery voltage on 440 to 642 volts to a stable 750 volts DC link during discharge, and steps it down during battery charging. Volt DC link, smooth by decoupling capacitor banks C10 through C15 and lead resistor NR10 to NR13. Power then enters the three-phase, a two-level inverter built around the Q3 silicon carbide module, rated for 1200 volts and 100 amps. Rated module converts CC into high-efficiency three-phase AC power across negative U, V, and W. To the grid, the AC output passive from an LCL filter LF1 and LE1 and common mode choke CMC1 to eliminate high frequency double MEM switching harmonics. Finally, an grid interface links to 400, 230 volt and 50 Hz TNS utility grid via contactor K2 and a 125 amp MCCB breaker stacked by C-surge protection STD2. Supporting the primary power path in the auxiliary electronics with a 60 watt auxiliary power supply PCB taps directly off the high voltage battery bus to power internal control loops. A dedicated 10-channel gate driver PCB drives the silicon carbide weekend, while the main control PCB on a dual-core TMS320 DSP and an STM32 safety processor, and communication is handled by isolated CAN bus, RS485 Modbus, and Ethernet TCP interfaces to all hound bin IP50 or rated enclosure, and it completes the power pair from LFP cell all the way to the grid. Thanks for watching.